Michael Lucas is a author, best known for many different works, including Absolute FreeBSD, also SSH Mastery, Tarsnap Mastery, Ed Mastery, many mastery books, DNS, Sudo, yes. So, and also a bunch of fiction books as well.
IPsec? No, my life is still worth living.
DNSSEC, though.
DNSSEC.
DNSSEC?
My life was barely worth living then.
In your hand?
Don't think so.
Okay.
There.
Should be, yeah.
That whole face of that thing flips open. The face of the podium.
Face of the podium.
That whole wood grain thing.
Oh, that's lovely.
Isn't that nice?
So that's what happens when your library has a budget.
Yeah.
Cool.
When we pay them $90 for
Ah. Okay, this. Yes, I'm running Windows. It's in my FAQ. Why? So.
There's this really great operating system, Linux.
It's in his FAQ.
It's in my FAQ. And also, the immediate threat of violence to anyone who doesn't read the FAQ but insists on pushing that. So,
I haven't read it, but I've heard it.
oh, yeah.
Better read the FAQ.
Okay. Good evening, folks. Actually, before I start, where's the range that this mic works?
It's pretty much like a conical range.
So I'm like I have just a few feet
You just
here.
have a few feet, yeah.
Okay.
Change it up if you'd like, but
No.
okay.
If I need to pace, I will just turn, and then we make it work. Hi, folks. Thanks for having me. My name's Michael Lucas. I write technology books, and the latest one, fresh off the printer, is the new edition of Absolute FreeBSD. It is not yet in stores, but the publisher rushed a few copies to me so I could bring them tonight, and I haven't dared open it yet because now is when you find the typos. And really the only thing I can say authoritatively about it is that it weighs 3.5 pounds. So it's not quite ballast, but close. So I've been running Unix since the late 80s and been a practicing sysadmin since 95. I'm a founding member of the Southeast Michigan BSD user group. I've been pushing BSD now for years and years and years. And I've written 30-odd books, mostly on tech stuff, but you'll also find some novels like Git, Commit, Murder. And I do some other things. So, anytime I come to a Linux-heavy group and talk about a BSD, I feel compelled to put this in. Saying I excel at this is not the same as saying you suck at this. It's only ugly if we let it be ugly. I'm not trying to run anyone down. There are differences between FreeBSD and other BSDs, Linux, Illumos, AIX, whatever. I'm going to talk about places where we beat out competition. But your favorite OS beats FreeBSD out somewhere as well. When you dig into things, though, you'll find that the developers of all of these things hang out together in the bar at a con. You go to something like Unix, and you will see BSD folks and Linux folks and Oracle folks in the bar hanging out and debating ideas back and forth. And competition is a good thing. Your successes goad BSD folks to do better. Our successes goad you to do better. And really, when it comes down to it, we all agree that at least the other people aren't Oracle. So we have that going for us. So, what is FreeBSD? A freely available, open source, Unix-like operating system. How many of you folks here have run FreeBSD? How many of you have used some BSD? Back when it was called Sun OS, that counts. It's derived from original AT&T Unix. Now, it's been a long time. Very little original AT&T code remains. Anyone who's still using AT&T code from 1992 probably needs to take a look at their code. There was a whole scramble of little forks when original BSD came out, and FreeBSD is one of the survivors. Founded in 92. The primary platforms right now are AMD 64 and i386, or as I call it, AMD 32, because nobody really bought that pricey Intel hardware. Come on. Up and coming is ARM64. FreeBSD targets popular computing platforms. And for something that very few people have heard of, FreeBSD pushes 25% of the internet's traffic. It does a lot of heavy lifting. So everybody here is a professional sysadmin. I'm not going to go spell things out too much. One of the things that comes up with FreeBSD and any BSD is the BSD license. A lot of folks like Linux. It has the GPL, which is basically a share and share alike license. Here, you can have this cool thing, but if you do something with it, send me your changes back. And that's cool. We try to teach our kids to share and share alike. The BSD license is very different because it has different goals. And the license these days really boils down to don't claim you wrote it, don't blame us if it breaks, and don't use our name to promote your product. And it's commerce friendly, but so what? You can't really close off the code. People have taken FreeBSD and OpenBSD and whatnot, and all of them have been forked off into little commercial things, and that really doesn't work out well for people who do it. You can use FreeBSD and any BSD commercially, but there are ways to be successful at it. And so who's really using FreeBSD? A lot of ISPs do, lots of small organizations, and then you have companies like Netflix and Dell and Juniper Junos is a heavy lifting router operating system. It's designed for OC48 optical links. That's based on FreeBSD. NetApp, a lot of storage systems are FreeBSD under the hood. Sony, how many folks have a PlayStation 4? You're running FreeBSD. And Apple OS X, or Mac OS, I think they brand it as now, but whichever it is. That's great big piles of FreeBSD in there. Most of these companies contribute something back. If they don't, that's cool. And the ones who really use it employ FreeBSD developers to push changes back upstream. So who are the developers? There are about 400 committers. And these are folks who have direct access to the source code and can make direct changes with no immediate supervision. Now, community members and other committers watch what gets put in. But if you're a committer, you are basically trusted to make changes correctly and to not screw up too often. And when you do screw up, to take people pointing it out well and fix your things. Outside of that, there are thousands of contributors, people who send in patches and bug fixes and even bug reports. All of these people help to improve the OS. And beyond that, of course, millions of users. So what makes FreeBSD special? First of all, it's a complete operating system, which is what you find in general in BSD. Linux, strictly speaking, is just a kernel, and people bundle it together into operating systems by picking packages and how those packages are built. So FreeBSD basically takes responsibility for everything they ship. And we'll see how that plays out in a bit. FreeBSD is known for very fast networking. It supports a variety of protocol stacks, some of which you've never heard of. Anyone actually running SCTP? It's a thing. Very few people need it. I hope one day to meet someone who does. And a while back, there was a company called WhatsApp, and they ran their whole company on FreeBSD. Facebook bought them and ported the app over to Linux, and Linux fell over. And Facebook actually has hired Linux devs to improve the Linux networking stack so it can handle the WhatsApp load. Now, this is an example of competition being good. I want to see Linux handle that load. I want to see FreeBSD improve in response. We all win at this. So another thing that FreeBSD has is many file systems for different uses. A few months ago, I gave a talk here on ZFS. Please take that entire talk and insert it into this talk right here. And I believe that's online.
It is.
So it has part of the storage system is something called GEOM, which is stackable storage. And that's where the encryption layers go. Package management and package building is integrated into the operating system. If you get FreeBSD, you have the tools to build packages. Updates these days are binary, so are upgrades. FreeBSD can run Linux. programs. It has an extensive lightweight virtualization system that has been kicking around since about 2000, and the documentation is extensive. But one thing that kind of confuses people is how FreeBSD is released. If you go to the web page right now, you'll see 10.4 release and 11.2 release. 12.0 is coming very soon. That seems sensible, but then you'll see references to things like 10 stable and 12 current. What do these words mean? Well, FreeBSD current is the latest bleeding edge where the newest code gets committed. Now, the developers test their work. Many of them have entire farms of machines where they test their work. But no one developer's test lab is nearly as extensive as the real world. So if you're running current, you take the risk that your hardware interacts with a new change in some subtle way, and it calls up the National Security Agency and puts you on the terrorist watch list. Not that this has happened, but it could destroy your data, could destroy your machine, who knows. Latest bleeding edge. And install images are rolled off of current every few weeks. Current is a single straight line of development from FreeBSD 2 in 94, I believe, all the way to the present day. Right now, 12.0 current is being polished for final release. FreeBSD only does a release when it is ready. So they're working on some final tweaks with this latest OpenSSL integration. So soon, 12.0 release will fork off of current. Current will be renumbered as 13.0 and just keep going straight. Stable refers to a FreeBSD release where the ABI and the KBI are expected to be stable. They're not going to change. Current, if the kernel interface needs to change, fine. We're bleeding edge, deal. If you're running 12.0 or 12.1, your interfaces are expected to be stable. So changes that don't churn the system get backported from current to recent releases. So 12.0 stable is actually 12.0 plus backports from current. New device drivers, new options to commands, new features that don't churn the system. And eventually, 12.0 stable becomes 12.1 release. And, I missed, we have a word in FreeBSD land, POLA, principle of least astonishment. In the middle of a release, don't port back something that will make the sysadmin go, what is this? You don't want to astonish the sysadmin. It's stable. Put the stuff that's going to freak them out in current and put it as part of the next release. So, releases are not perfect. So, you will get security patches to releases, and those get tags like P1, P2, P3, and updates are very quick and easy to deploy, so security updates and stability updates are released not infrequently. Some releases get more than others. Anyone using OpenSSL is accustomed to security patches. That's just life. So, that in general is how FreeBSD releases work. So eventually, 10.4, there may or may not be a 10.5, but they'll stop issuing new ones of that. 11 will be the older, more staid branch. 12 will be the newer releases, and 13 will be current, and this will just keep cycling forward forever. System configuration of a FreeBSD box is all handled in one file. I'm talking about the system itself, not add-on daemons and such. etcrc.conf. And it's all set with variables. Do you, for example, here, I've set a host name. I have a network interface with an IP and a net mask. I've set a default router. And no, you don't have to use hexadecimal net masks, but I did, for some reason at the time I set this up and never went back to put anything normal. Enable and disable daemons. Some daemons, like named here, you can set command line flags. All daemons, if they need the flags, you can set them here. You can either edit this by hand or use the sysrc program, which, if you're managing in the cloud, can be very useful. Similarly, there's an etcrc.conf.d directory where you can have individual files for individual daemons, which, if you're running something like Ansible, can be very useful. So, let's talk a little more about networking. Original BSD had the first TCP/IP implementation. It wasn't very good because the first of nothing is good. But the kernel architecture is designed to accommodate new network stacks. Pretty straightforward. That's why you get things like stream control, transport protocol deployed there. A lot of standards require 2 implementations of a protocol before the protocol can be declared a standard. So FreeBSD gets a lot of those. Not all of them are brought into the main source tree, but the fact that an implementation exists is enough to satisfy the standards bodies. They were some of the early IPv6 test hosts through the Kame project. It does aggregation, it does VLANs, etc. One thing I think is kind of fun is you can dynamically change your TCP congestion control algorithm. New Reno is the congestion control algorithm we have used for decades now, but it's really not suited for 10 gigabit links, let alone 40 gigabit. And there are a bunch of congestion control algorithms now fighting it out for dominance. Who will be the new Reno? I'm just really glad they didn't call any of them new Reno. Never call anything new, because one day it won't be. So, and you can change that on the fly by loading a kernel module and setting a toggle. And they do drop old stuff. IPv6 is native, so the Kame is gone. Anyone remember network protocol? That's long gone. IPX is gone. ATM is gone. They come, they go. So, Geom. FreeBSD has a lot of storage options. Heaven help me, I wound up writing 4 books on FreeBSD storage because I wanted to write a book on virtualization, and those were prerequisites. Geom is a neat feature, though. Most commercial volume managers say, we support RAID 5 and this is how you do it. Or we support RAID 10 or encryption or what have you. And you have to adjust your hardware to match that, and there are limitations. Geom, the key principle to Geom is you know your hardware. You know what you need in your environment. Why are we telling you what to do? You tell us what you want. So, the standard these days for high-end speedy storage is often RAID 10. But sometimes I've talked to people who had legit uses for RAID 0+1. And Geom lets you do that. You start with your physical storage layer. You add a Geom layer on top of that to perform a transformation. You add another layer on top of that other layer, of that first layer, to perform another transformation, and arrange it however you want. It is Tinker Toys for your storage layer. Most of us, if we have to encrypt a hard drive storage, for example, we will assemble everything into, assemble our disk array into one large container and then encrypt the whole thing. There are environments where they expect every disk to have a separate encryption key, which is kind of a pain to manage, but okay. So Geom lets you encrypt each disk separately and then apply the RAID layer on top of that. So you know what you need. Assemble it whatever way you want. So, and one feature everybody needs these days is storage encryption. My personal favorite use for storage encryption is for financial data. I'll encrypt the disk when I install it, so that when the time comes to decommission that disk, pardon me, I just destroy the key, and that disk is scrambled and no one's going to be reading your data. It's also useful for laptops if you have confidential data that may be stolen. Now, I still am accustomed to, whenever someone says that they've encrypted their hard drive, I still expect to hear from them months later that they've lost all their data because they've messed up the encryption somehow. That's just a rite of passage. You'll go through it. Backups are good. FreeBSD has 2 encryption layers, Jelly and GBDE. And Jelly is the friendly, happy encryption. This is what you want for your laptops, for your financials. It has multi-passphrase support for corporate environments. So if you are a high-level engineer, you have company confidential data on your laptop, so it has to be encrypted. But the laptop is company property, and the company security officer must be able to decrypt your laptop for standards compliance or regulatory, what have you. This is what you use. You can put key files on USB drives. You can encrypt with passphrases. All the things you would expect from a commercial grade storage solution. GBDE is a little different. when Paul Henning Camp put this together, he studied case studies of embassies that were attacked, wars, a bunch of really ugly situations. And GBDE is designed to protect the user where possession of this data may be a threat to your life. So you can hide data inside other file systems. You can hide it in Windows swap partitions. Now, if as I was researching the encryption storage part of the one book, I made a decision that if I ever looked at a job and thought that GBDE would be useful for the job, I would turn the job down. That this is one of my red lines, but this stuff saves people's lives. Because frankly, if someone comes up to me and puts a gun to my head and says, type in your passphrase, I'm going to type in my passphrase. I'm not even going to ask if the gun is loaded. But I want the operating system to say, the passphrase is correct, but the data has already been destroyed. If it just says cannot decrypt data, well, I'm a dead man. But if it says the data's been destroyed, what that's really saying is this person still has value as a hostage. He's trying to cooperate. Please don't shoot him. And I like that out of my encryption. Thank you. So, happy topics now. Packaging. Everybody likes packaging. Now, FreeBSD ships as a complete operating system. It's not packaged. There are people looking at how to change that, but even then, base packages would not be the same as add-on packages. There is a distinct, hard separation. The user directory above user local is just for the operating system. User local is for add-on packages. Home is for you. And what you'll find under the root directory is somewhat replicated under user local. User share examples is for the base OS. User local share examples is where package examples are stored. Etsy, user local Etsy, and so on. So what goes into packages? FreeBSD is deliberately small. It's a lot smaller than, say, Solaris. It's a lot smaller than Ubuntu. Complete base install with source, less than a gig. Now, there are minimal installs that of everything that will shrink it down to 200 meg. I'm not arguing that. But on average, base install, defaults, fairly small. Things that are in packages that you might expect to see in the base, sudo, vim, FreeBSD ships with NVI, which is another type of VI that is good enough for most uses. X, GNU-PG, Nmap, Emacs, LDAP, modern mail clients. This is your system. You know what you're going to use it for. Why install X if this is a server? So install only what you need. So FreeBSD had this really innovative packaging system that they came up with in 1994, I believe. At the time, it was brilliant. In 2014, not so much. So there's now a packaging system called PKG, and the command syntax should look very, very familiar to anyone who's used any packaging system in the last 10 years. Package install this, package upgrade, search. Some nifty things I find useful. You can lock a package so that it will not be upgraded. For example, I once had to rsync with a, I think it was a Solaris 7 box that had this positively antediluvian rsync server. Not even over SSH, rsync. And after like 15 years, they dropped, rsync dropped support for the ancient version of the rsync protocol. So I had to go find, and my package upgrade blew away the version that supported that. I had to go scramble around, find the older version, install it, and lock that package so that upgrades would not touch it. So now there is a package command on the system, but the only thing the base system package command does is bootstrap the package tool in the packages collection so that packages and the package tooling can stay synchronized with each other.
So does the package lock all the dependencies too, or just the actual package?
Does the package lock the package itself or the dependencies? I would have to double check that. So, however, there is a package-lock man page where I'm sure that's documented. So, and in the package tools, there's a database that's SQLite. You can query it, you can search it. One nice thing about FreeBSD is the packaging source code ships with the operating system. They're called ports. It all lives in user ports. It's an optional install when you put your system on disk. Right now there's about 33,000 ports. And this doesn't include variants and flavors like with and without LDAP, with and without X. The Emacs port has 27 toggles that you can turn on and off for different Emacs build options. And before you go getting cocky, Vim is just as bad. So that's tens of thousands of possible ways to build just one program. So if you don't like the way FreeBSD packages Emacs, go build it yourself. Build Emacs with LDAP support. I don't know that it does support it, but I don't know why it wouldn't. There are flags for licensing and redistribution. For example, some of the software that appears in ports, you are not allowed to redistribute pre-compiled packages. So there is a flag that says don't build redistributables that FreeBSD's port building tree uses to build packages for the FTP servers. There are flags for licensing. If you are building a commercial product and the legal team has come down and said, whoa, no GPL, no MPL, no Apache 2. You can set flags in etsymake.conf and say, okay, we're forbidding these ports, build everything else. There are also checksums to catch file damage. The thing to remember here is there is no third-party code in the ports tree. If you go to build Apache, what you get from the ports tree is, here's the site, here is how you build it, here's the compiler you need, here are any patches you have to add for things like put it under user local or what have you. And It's just instructions for reproducibly building the software. When you type make install, it goes out on the internet, it grabs the source code and pulls it down. So everything is checksummed. There's been more than one occasion where an intrusion in a third-party piece of software, I'm not going to name names because it happens to everyone eventually, where the FreeBSD ports tree has caught a change in the software author's tarball that they provide containing the source code. And it's because someone entered a few lines of code that shouldn't have been there. So, don't just disable checksums. I shouldn't have to tell anyone in this room this, but if you're watching this on YouTube, don't disable checksums. Also, if you're releasing software, please give it discrete version numbers so that people can reliably checksum your release files. So you can go in and, yes, this is Emacs 26. You can just go down the line and check and uncheck what you want, what features you want. Say, my hosts, I don't run X on any of my servers, so I install a version of Emacs without X. There's GNU TLS, because your text editor needs to speak TLS. Of course it does. Fine. Whatever it is you want, you can do. FreeBSD also includes the software to build your own packages en masse. Say your environment, you need not just LDAP. You need a particular version of a particular LDAP library. And it's not what FreeBSD provides, so you have to build every package for all of your hosts. And if you're on Linux, you've got to go run around the net and find the package and find the repo. And often those packages are built on some developer's desktop, and who knows what dependency crept in, and it could use some improvement. So with Poudrier, it means powder keg. The previous system was called Tinderbox, and the author of this system is French, so we get his language, thanks. You configure your packages once, you build them once, and can distribute them everywhere with your own package repository with one command. You can build for the release that is running on the build host or any earlier release. If you're running FreeBSD 12, you can build packages for FreeBSD 11 and 10 on that same machine. You can build i386 binaries on 64-bit hardware. You offer your clients packages by whatever protocol your network uses. The important thing is that they can access it. If you have a lot of packages to build, you can use memory file systems as build space out of the box. And as with any huge build, has anyone here used Ccache? If you have to build really big stuff, and a lot of it, and build it everywhere and over, look at Ccache. It will slash compile times. At one of the dev summits, I heard that Ccache cuts compile times 80-90%. Of course, you're building 9 different versions of Emacs. So, and the package building is one thing that really sets FreeBSD apart. So let's talk about patches and upgrades. FreeBSD supports binary upgrades via the FreeBSD update program. Again, this should look pretty familiar to anyone who's used an update program. It's a separate program because FreeBSD is shipped separately as a whole OS. But fetch and install your updates for patch levels, upgrade to a new release. The ports tree has its own update utility, port snap. And pretty much if you type port snap auto, port snap goes and does the right thing. Either you want your ports tree updated or you want a fresh ports tree installed. That's about it. There are options to roll back updates, but who cares? And package updates happen in package itself. So, running binaries from the wrong operating system. One neat thing about primordial BSD way back when is that they implemented multiple kernel binary interfaces. And every program had a brand to say this binary uses this kernel ABI. So FreeBSD can run Linux binaries not as an emulator, but just as a matter of course. This is what we do. Currently, they're emulating 2.6.32 with 4.14. I think it's 4.14 just coming out. 4.19. The newest Linux long-term support kernel. This is due for a rev. There are user lands for CentOS 6 and 7 in the ports collection, and it runs effectively in a CH root. There's add-ons for linproc.fs and linsysfs because these are important in Linux land. And this is not a thing that was just added on for Linux. In the past, they supported OSF1, they supported SCO, System 5 Release 4 used to run on this, but that support was dropped because nobody used it and nobody cares. People actually run Oracle on this. So it's fairly solid. This is a little bit dated, but the special effects for the Matrix were done on FreeBSD hosts because the Linux special effects software ran better on FreeBSD than it did on Linux. Now, again, that's a little dated. Linux has caught up. FreeBSD has gone ahead. Keep chasing. It'll all be good. And another part of this, part of that kernel ABI is FreeBSD includes support for other FreeBSD versions. So, kind of like containers, FreeBSD has been providing jails since about 2000. It uses the host kernel with an isolated process context, isolated networking, and isolated file system space to give it the illusion of a standalone system. Users can identify that they're in a jail, but they can't get out. One neat thing you can do is you can run multi-interface jails without any processes in them and use them as firewalls. Packet filter firewalls. You can't run Squid without a process. Thank you. You can manage jails either from the host that they're on or run an SSH daemon on them. And when you do this, you run only essential features on the underlying host. So, some things you can do. You can use ZFS clones to create multiple almost identical jails. You can use a single OS image and loopback mounts to create multiple similar jails that you can simultaneously upgrade. So you update one directory containing an operating system instance, restart your jail, and boom, everything's upgraded. You can run any FreeBSD older than the host, all the way back to FreeBSD 4. Yes?
So the networking on this, could you set up like micro-segmentation and separate the different jails and put them in different subnets?
Yes, people subnet them all kinds of ways. There are virtual network stacks in the FreeBSD kernel, so plug them together however you want. Again, FreeBSD provides tools, not policy. Their goal is, or their basic idea is, you know your network, you know your needs, you know your hardware. Have some tinker toys. So, yeah, at my last real job, there was a server, and I use the term loosely. It was a repurposed desktop machine. We've all run those. It ran FreeBSD 4, MySQL 3, PHP 2 point something. This dated about 2005, and it was a mission-critical machine. It ran a custom app written in-house that nobody dared touch. And yet this piece of hardware, it was old when it was repurposed as a server. Because that's when desktops become servers, when they're too slow to run a desktop anymore. And the machine was completely terrifying. I tarred up the server, everything on it, even including the source code files for the PHP 2 and MySQL 3 and what else, because who knew if I'd ever find those again. Installed it in a jail, lopped out a bunch of things. I don't know anyone who wants to run 2005 OpenSSL on the public internet. But I was able to use the host's packet filter firewall, turn off SSH on the jail, we'll manage that from the host, and only allow the office access to that application. So this still isn't good, but at least there's a modern hard drive under it, and it can be somewhat protected by something from this decade. So a jail is incredibly useful. And we wound up with things like I removed the jail's PS binary and put in a statically linked one from the host so it could read process information from the kernel. That's normally not a problem, but this thing was so old that it wasn't good. But at least it was a solution. Yes?
Is it still running?
No, that company no longer exists. I know people who have done similar things, and yes, they're still running. And they are locked down as tightly as possible away from the public. That is not, they're all custom apps that nobody wants to touch. I still know companies that are running Novell NetWare 4 somewhere, because you really could do a neat talk one night here on technical debt, but the whole meeting would devolve quickly. So you can control what jails get what file system, who can mount new stuff. Do you want to share System 5 IPC space or not? You can run Linux in a jail. And you can control how many resources a jail can use. Configuration looks pretty simple. Variables. Here what I've done is I've set up some defaults for my jails. And then I define a jail just with a name and the IP4 address. And the rest of the jail just gets configured off of those two variables. Okay. How many of us really, really hate SSH scanners that fill up our logs and just spew garbage, and we have to wade through this crap looking for the stuff that matters in our daily reports? Stuff like fail to ban and other programs that read log files and parse them out looking for solutions. They save us pain of going through that by imposing other pains. And the nice thing about log parsers is you don't have to be a C programmer to implement them. But the bad thing is that they're really solving the problem the wrong way. FreeBSD it uses BlacklistD, which it was originally came from NetBSD, but the library gives a program a way to say, this IP is behaving badly, and feed it to an external program that can send commands to the firewall. So you whitelist your administrative IPs and have the SSH server knows better than the log file who's behaving badly. And I don't want to give an IP address 3 chances to connect to me. I'm using key-based authentication, and I'm from my whitelisted admin IPs. If someone logs in and tries to use password-based authentication, they're out. If someone tries, there's all kinds of conditions that the program knows about that the log doesn't. libblacklistd lets you feed this to the firewall. And personally, I really want to see OpenSSH either implement this or something similar, because if OpenSSH picks it up, all of a sudden it's a standard. And BlacklistD can feed any of the 3 FreeBSD firewalls. And this is the point where people usually go, wait a minute, 3 firewalls? What is this? Yes, FreeBSD has 3 distinct firewalls. And not like FirewallD and Firewall Config that all feed IP tables. No, these are 3 different packet filters. PF is the current standard. It was ported and forked from OpenBSD's PF, or as I call it, porked. IPFW was the original packet filter. It was great for 1998. The fact that you could filter packets at all on a Unix machine was wonderful. IPF is a cross-platform packet filter. If you need to filter packets on Solaris and IRIX and FreeBSD and Linux, IPF is an option for you. The short answer today is use PF. We all know the word firewall basically is meaningless, but these are all packet filters, and as a packet filter, PF does the best job. The senior FreeBSD cluster maintainer, Peter Wem, has said that if he couldn't get PF on FreeBSD, he would rather run OpenBSD to get PF to protect the firewall, to protect the FreeBSD cluster, rather than use IPFW. It is the modern firewall. 80% of people use it. That's where the love goes. And anytime I talk to people who use a bunch of Linux, I'm compelled to show some sample PF rules, which, if you know anything about packet filtering, this is very readable. We set an external interface. We have this set skip on LL0, which is tell the packet filter to skip the loopback interface, because If we have to filter on loopback, we've done something wrong much earlier. We're already in trouble, yep. Scrub in, that means reassemble packets, throw away weird tidbits that don't seem connected to anything. Block everything in, pass everything out. And then we have a list of ports that we pass in TCP packets on these ports. We pass in UDP on these ports. And we pass in ICMP and ICMP6. Yes, you can more specifically block ICMP, but that made the type on the slide too small, so. And this, I find this much more readable than your typical IP chains rule set. Okay, another neat feature you'll find is libarchive. Maybe a decade ago, poor Tim said, I want to write a new installer for FreeBSD and a new package manager, but I've got to be able to handle all of these files. And he wound up creating libarchive, which is a general purpose archiving program. A lot of FreeBSD features are built on this. It opens everything. It writes everything. It is the Swiss Army knife of archiving programs. You can untar ISOs on FreeBSD. And you can use tar to create ISOs. Or CPIO, or different SHAR files, whatever. The sad part, of course, is that he got so tied up in this that someone else had to write the new installer and someone else had to write the new package manager. But BSD tar opens everything. Yes, sir?
Are those re-implemented internally, or do they call out the helper programs?
Oh, that's all in part of the library.
Nice.
Yeah. And a lot of systems now ship this as BSD tar. So there are documented incompatibilities in the man page, and it is stuff like, this commercial tar program from 1994 includes file attributes that modern UFS does not support and BSD tar can't read. Well, fair. But they're documented, so you know. So, BSD in general, and FreeBSD in particular, is self-hosting. This means it ships with the code and the tools to build it. So, if you do a complete FreeBSD install, including source code, cd user source, make update, make build world, make kernel. You've downloaded the latest source code, built the newest one, reboot on the new kernel, install the new binaries, you're running the latest. And you can set options for custom building. Now, some options are better supported than others, and there are people working on a comprehensive audit of all the options. But you can build with different compilers. Depending on which compiler you pick, it may or may not work because compilers come in and out of fashion. Anyone remember ICC, the Intel C compiler? That was a supported option for a while because they really wanted multiple compilers. And now that Clang is out with all of those pluggable this and that and stuff I don't even pretend to understand, but I'm sure it is very cool. That's how that's done. Yes, sir.
I'm trying to understand how you get started in this so that you can just compile basically from source. You've got to be running this in something, right? So how do you get to that point where you have something that's running that then can...
Well,
You're talking about upgrading a current one?
Upgrading an existing install. If you are running current, this is how you get the latest current. If you're running FreeBSD 11.2 and you decide that you want to upgrade to 11.3, by building it yourself, you can do that this way. You have to set a couple options that say, build this particular release. Or if you're doing, say, if you're a developer and you're trying to figure out when was a bug introduced, you might do this several times in a binary search to narrow down when something broke. So this means you can tweak the operating system. You can very easily go into the source code and change it and build a new release that has your exact needs on it. Of course, the devil is in the details of this. Supporting that release is your problem. We have everyone who's been around FreeBSD for any length of time has had some bright idea, built their own world, and discovered why that was a terrible idea. But it's great to be able to learn that way. Because really, pain is the best teacher. None of us like to go to his school. But inspiration takes you straight to it. So, and as part of this, it's very easy to enable crash dumps and tracebacks. If you're running Linux, you have to install and configure kdump. Here it's just turn on a dump device. Once upon a time, you needed an amount of swap space equal to the amount of. Now that we have machines with a terabyte of RAM, that becomes something of an issue, but most dumps now are very small text files that just spell out where everything went completely horribly wrong. And yes, you can still get those old style of full memory dumps, but you have to turn those on, and chances are you've done something really, really special, if that's what you need. I haven't heard of anyone needing that in years now, but it's still there, and people still test that. So, FreeBSD is also considered self-documenting. All of the resources that you need are under freebsd.org. There are third-party documentation sources out there. People run their own forums and whatnot. You're welcome to do that. But the main project considers it important to provide all of that. Everything has a man page. If there's no man page, it's a bug. If the man page is wrong, it's a bug. There are forums, there are mailing lists. So, the two sources you should know about are the handbook and the FAQ. The handbook is long form answers, detailed tutorials for new users who are trying to figure things out. For example, how do you install a GUI and use a GUI? It's in the handbook. The FAQ has short answers for short questions. So, how does all this happen? How do the developers work? Most development and discussion is on mailing lists. You'll also find reviews.freebsd.org for patches. And that is I've completely forgotten the name of the software, but it's perfectly standard software for reviewing patches. And if you look at reviews.freebsd.org, Fabricator, that's it. Sorry, brain lapse. A main source code repo is Subversion. There's constant automated build testing and CI. The ports tree also does experimental runs for things like X upgrades, KDE upgrades. You know, let's upgrade it all to KDE 4 and see what breaks before we push it to the users. All of this, of course, is done by people. kernel developers, userland developers, third-party software integrators. You know, I'm not sure off the top of my head who maintains Vim or Emacs, but they're saints. And if that's the only thing they do for FreeBSD, bless them. Documentation writers, advocates, podcasters, tech supports, you know, the usual crowd you find around any open source community. And it's a very vibrant community. Go to a BSD conference, and frankly, they won't shut up. It's a lot of fun, high energy. And I tried to make this talk short. We're clocking in at 1 hour and 8 minutes. Whew. Not quite as short as I wanted, but so we have some time for questions. Before I answer them, the IRS compels me to say that I write books. You can buy these books. So my mileage is now tax deductible. Thank you. Are there any questions? Yes, sir.
What's your opinion on FreeBSD looking to drop 10100 network adapters from their source tree?
A 10100 net. Okay. I don't believe they're actually going to drop 10100 network adapters as a class. I suspect they'll drop specific 10100 adapters. FreeBSD targets popular hardware. There are very few pieces of popular hardware that still have 16-bit ISA slots. And cards that only go in slots you will no longer find could and should be dropped. Also, FreeBSD is a community project. If nobody's using the hardware, if nobody's willing to support the hardware, if nobody has the hardware to support it, then it needs to go. Because it is better to not have the driver than have the driver and not be able to test it and support it. Now, having said that, code has previously been dropped only to have all of a sudden people come out of the woodwork ready to support it. And it gets put back in. And that's as it should be. Because if nobody's using it, let it go.
So if you have a bucket of Recon 905 and 509.
Yes. If you have a bucket of...
Fives are PCI.
I know.
Yeah.
Yes. If you have a bucket of old crap,
I can see any
And you-
2000 cards getting,
yes.
getting shredded.
Oh, yes. There are a long list of hardware parts that should no longer be supported. It's not popular hardware. If you're truly running it, you can still download FreeBSD 2.0 from FTP Archive, and it will run perfectly well on your 386. And there are embedded applications that seriously need that haven't moved to ARM yet. I mean, last I heard, NASA is still using the 486 because it's a well-understood processor.
It's also a large processor, so if you're dealing with cosmic rays or whatnot.
Yes. Yes, there are solid use cases for this old hardware, and the code's still available. Go download it. Have fun.
Does I maybe covered this and I missed it. Does it run anything other than x86?
Um, it,
Those things?
there are FreeBSD has tiers of hardware support. Tier 1 is i386, AMD 64. ARM 64 is rapidly heading towards Tier 1. ARM, as I recall, is a Tier 2, which means it's pretty good. It's on the way in. There are Tier 3 and Tier 4, where you'll find things like, the S390 mainframe, old Apple hardware, the IBM, the Japanese PC98 standard, which is a 386 plus, special Japanese something. And so Yes, there are other platforms. It targets popular stuff. ARM64 is popular. ARM is sort of popular. MIPS is in that list somewhere. There is a tiers page on the FreeBSD website that says exactly what is where.
From chat, another advantage of the 486, no speculative execution attacks.
Oh, yes, yes. Speculative execution on a 486 is very difficult to pull off. Tom, you actually rose your hand like a civilized person.
I don't usually be civilized, as you know, but what do you think, Warden versus IO Cage? Do you like the move to IO Cage, or?
I like the move to IO Cage.
Seems simpler to handle so far. I seem to grasp it better than Warden.
Yes, the question is Warden versus IO Cage for jails. For my jails book, I'm specifically covering IO Cage. There are several FreeBSD jail managers. The base system is fine for handling jails. Once you get to 40, 50, 60, 300 jails on a host, which is entirely possible, and once you want to start doing some DevOpsy stuff, having a jail manager is very nice. Just as for everything else. And some of the popular jail managers are obsolete. Some of those that have been kept up to date, I judge tools by a variety of characteristics, including, is the person who runs this project a jerk? And if so, I don't recommend the tool. But IO Cage, pretty solid, responsive developers. And I have been methodically testing IO Cage functions for the jails book. And so far, they have not sent me a beastie's head in my bed as a warning to make me stop. They're fixing things pretty quickly.
FreeNAS is moving to it, the 11.2.
FreeNAS is moving to it. IO Cage is the future of large-scale jails management. There's also CBSD, which is nice. It runs jails as well as Beehive VMs. So if you need to do both, that's an option. I'm not covering it in the jails book because I'd also have to cover Beehive, and that's a separate book. So, and the jails book already threatens to be maybe not 3.5 pounds, but 2. 2 is a possibility. Other question? Yes, sir.
So following the principle of least astonishment, I know that when FreeBSD integrated PF, after that point, OpenBSD changed the syntax of PF.
Yes.
Will that syntax change be pulled into FreeBSD at some point, or will they continue with the old syntax because it's not astonishing? It would be astonishing to change it.
Okay, question is, will FreeBSD catch up with the OpenBSD PF syntax? The short answer is the FreeBSD PF is effectively, it's a port and a fork. There is no impetus to catch up. FreeBSD, it has a very different locking model and different kernel locking model and attitude than OpenBSD. OpenBSD is doing some work right now on their locking for multi-CPU support. There is no impetus to catch up with OpenBSD syntax just for the sake of a syntax change. Any other questions? Yes, Tom.
Maybe you covered at the very beginning, but the speculative execution,
Yes.
the BSD people, they seem to be left more behind than the Linux kernel devs and the Microsoft devs were to update that. Can you elaborate on that at all? I've heard rumors, but...
Yeah. Okay, the BSD community and speculative execution and Intel keeping them up to date on their dirty laundry. No, the BSD communities in general have not been kept as up to date. People are actively working on addressing that. Linux gets a lot of noise. They have a lot of attention. Now, in a couple weeks, we have MeetBSD which is a BSD conference in Silicon Valley, and it's actually being held on the Intel campus. And there will be discussions. I'm kind of curious if some of the BSD developers in general have a very hard-nosed attitude about speculative execution. And I'm kind of curious what kind of questions they're going to be asking. And again, I'm not going to name names here, but I expect the BSDs in general to be kept more up to date on that. People are working on it. It all comes down to people. A huge amount of InfoSec happens in the bar. It happens because of who you know. Personally, I'm convinced that if Mike O'Connor gets run over by a bus, half of commercial IT's InfoSec will fall apart immediately because he knows where everybody is. Fortunately, he works at home and tries not to leave the house, so we're good for a while. Any other questions? Yes, sir.
Yeah, this is a way off the wall question, but I'll ask it anyway. The Linux world has an excellent operating system. The BSD the FreeBSD Unix is an excellent operating system. Mac OS X is an excellent operating system. People curse Windows up and down. The perfect solution, you would think, would be Linux, except there are so many versions that if someone was trying to hire somebody, the chances are they wouldn't know how to work their version of Unix, so the corporate world cannot adapt 50 different versions of a similar operating system, having to train everybody for 6 weeks before they knew how to work it. Do you think FreeBSD Unix could be a good answer for the corporate world?
Could FreeBSD be a good answer for the corporate world? Of course it could.
On the desktop. In the
on the desktop. There is a FreeBSD branch called TrueOS. And I'm sorry, they just rebranded. But if you go looking for TrueOS, the new name will come up, I'm sure.
I thought that was the new name. They changed again.
Yeah, no, it was FreeBSD or PCBSD.
It was PC.
It was. You're right. Okay, TrueOS is the. I don't use user-friendly versions of operating systems. I want a Unix that is actively choosy about its friends and says, no, if you can't get a GUI on me, you don't deserve me.
There's so many ways to go wrong with that phrase.
Yes. But I think FVWM is a very heavy GUI. So, yes, people have made an effort to develop versions of FreeBSD that are friendly on the desktop, that are familiar and easy on the desktop. And there are companies using that on the desktop. For many of them, though, it is a technical or perhaps even ethical decision rather than one that's pure business. I mean, Windows comes free with every computer. And it's not really free. The price is rolled into it, yes.
Yeah.
But effectively, it's free. It's a steamroller where, then again, things change. Everything changes. I mean, 20 years ago, BSD was dead. And here we are today pushing a quarter of the internet. Illumos just had its knees shot out from under it as a community project, but I'm not going to write them off either. Someone may pick it up with the vision. And everything in open source is really done, really started by one person with a vision and the technical chops to get it rolling. It can happen. Yes, Brian.
Well, actually, it's an answer to his question, something that you have told me and other people, and that is a lot of times your application chooses your
Yes.
operating system
Oh,
as well.
often your application chooses your OS.
See the
Yep.
fact.
And everybody's using Microsoft Word
Everybody's using Word.
and Office.
Yep. There are programs like, Adobe has a complete lock on vast swaths of the publishing business. And yes, you can avoid it, but it's painful and inefficient. If you want to take on the desktop, the operating systems are ready. Give me a competitor to Adobe InDesign, because GIMP can compete pretty well with Photoshop.
Yeah.
But there's InDesign, there's Acrobat, there's a whole,
Scribus is your
there's a family of tools that all work together seamlessly. Give me an application suite that can compete with that. And then we'll talk about desktop Unix.
And those software, you either have to have a Macintosh or you have to have a Windows machine.
Yep.
And on that sad note, I think we need to wrap it up.
Yeah, let's wrap it up. I thought you had, oh yes, it's 8:30. I guess we're going to wrap it up. Thank you for having me.
Thank you.
And oh yeah, buy books.
Yes. Buy many of them. Buy multiple copies.
Yes, yes.
You have a handful.